Despite some unexpected challenges, team members are setting lofty goals for the rover in 2022. 1 year ago, NASA's Perseverance rover plunged through the Martian atmosphere and safely landed in Jezero crater, a 45-kilometer wide gouge that scientists suspect once hosted a deep, long-lived lake. The rover's ultimate target is near Jezero's western edge, a large, fan-shaped pile of sediments that washed into the basin through a notch in the crater rim about 3.5 billion years ago. In other words, the target is a river delta, the exact type of environment that could preserve signs of ancient Martian life forms. Perseverance is the tip of the spear in humanity's grand quest to find traces of a relic Martian biosphere. The $2.7 billion mission's overarching objective is to collect dozens of Martian rock samples, many of them from the delta. Then, sometime in the early 2030s, a sequence of spacecraft should return those samples to Earth for up-close scrutiny, possibly allowing scientists to at last answer the question of whether the solar system was ever home to more than one life-bearing world. Perhaps past microbial life could have existed on Mars when it was a little warmer and a little wetter, says Lori Glaze, director of NASA's Planetary Science Division. The surface of Mars, the geology, the geologic history, is preserved. We can see back 4.3 billion years on the surface. You can't do that other places. Perseverance's early observations are already revealing that Jezero's geologic history is richer than previously imagined, with dramatic shifts in environmental conditions. Now, as the rover ramps up its sample collection campaign, scientists back home are eager to send it west, toward the alluring river delta and its potential biological treasure. Mars, however, does not always play by the rules. Already the planet has thrown a few unanticipated challenges into the rover's first Earth year on the Martian surface. Every time we've sent a mission to Mars, we've had to learn more about how Mars actually is going to treat our spacecraft, and we have to learn how to operate in that environment, Glaze says. But Perseverance is doing well, she adds. Things are moving along at a really good clip. The team is making pretty great progress. Early science outside the landing strip. Perseverance is not alone in celebrating its first Martian anniversary. It was one of 3 space missions to reach Mars last February. The United Arab Emirates Hope orbiter is still circling the planet. And China's multi-component Tianwen-1 mission, composed of an orbiter, a lander and a rover, is there, too. That mission's rover, Zhurong, is currently exploring a Martian plain called Utopia Planitia, some 1,800 kilometers northeast of Perseverance's location. Back in Jezero crater, however, Perseverance's Martian adventures took an unexpected turn almost right away, starting with where the rover touched down on February 18, 2021. In all of the simulations that were done beforehand, the most likely place to land was a big, flat area that we started calling the landing strip right in front of the delta, literally within 100 meters of the front of the delta, says the California Institute of Technology's Ken Farley, the mission's project scientist. So we were joking around that on February 19 we were going to wake up looking at a wall in front of us. And, we didn't. As the rover descended to the surface, an onboard navigation system autonomously guided Perseverance to an area the software had deemed safe, which it was. But instead of landing within an Earth day's drive of the delta, the rover ended up about 2.5 kilometers away, on the other side of a treacherous, sandy, rock-strewn terrain called Saita, which is Navajo for amid the sand. Circumnavigating that patch would more than double the length of the rover's path to its primary exploration target. Yet as Perseverance scouted its immediate surroundings, mission controllers chose to let it linger on the crater floor and explore Saita before doubling back and heading to the delta. I worked on Curiosity ever since it landed in Gale Crater, says Perseverance's deputy project scientist Katie Stack Morgan of NASA's Jet Propulsion Laboratory, JPL. And, with that very first image that we got down from Perseverance, I looked at that landscape and thought, wow, we are not in Gale Crater anymore. This is nothing like what I've ever seen in Gale. Instead of landing in lake sediments, the rover found itself on fractured bedrock littered with bizarre, sometimes dusty rocks. Many of those rocks are covered in an intriguing purplish coating that resembles desert varnishes on Earth, patent is associated with hardy, radiation-resistant types of terrestrial microbes. Initially, the rock textures and geochemistry defied classification. But once the rover had ground through the weathered surface of a Jezero rock, scientists saw exactly what they would have expected in a lava flow, not a lake bottom. All of the rocks that we have confidently identified are igneous, Farley says. They have nothing to do with the lake. Produced volcanically, the igneous rocks on Jezero's floor contain large olivine crystals that typically form near the bottoms of thick lava lakes and flows. Scientists still do not know how or when the rocks ended up in Jezero, but it is now clear that the surface Perseverance is rolling across is not the original crater floor. Further investigations revealed that the rocks have been altered by water, which excavated small tunnels and pockets in their interiors that are now filled with salty minerals. At least on Earth, such minerals are perfect for preserving signs of life. Their presence, plus the mysterious purple varnishes, makes these volcanic rocks unexpectedly tantalizing targets. Igneous rocks are typically not where you look to find signs of life because they come from really hot magmas that life doesn't necessarily favor, Stackmorgan says. But when you have these rocks sitting on the surface or in the subsurface interacting with water, then you're creating small niches within the rock itself that could be habitable. You've got chemical ingredients in there, you've got water in there, you've got precipitation of salt minerals. As Perseverance cast its gaze farther afield, it spied Yezero's mountainous crater rim and the wall of the delta. We confirmed we do have a delta, so check that box, Stackmorgan says. It also spotted a curious rocky outcrop called Kodiak, which team members have used to gauge the depth of Yezero's ancient waters. Patterns on the rocks suggest that on at least one occasion, water levels dipped surprisingly low, falling to more than 100 meters below an outflow channel to the east. Other observations provide hints of a deluge that gushed into the crater with enough power to carry along the large boulders now haphazardly strewn in some areas. In other words, Yezero's lake was occasionally stable and placid and at other times flushed by periods of intense runoff. The rock layers of Kodiak.nd oddly, Yezero appears to be much windier than anticipated. Fortunately, that has not bothered Perseverance's robot friend, the helicopter named Ingenuity. Since April 2021, Ingenuity has been performing well, so well, in fact, that after its initial tests, the team began using it to help guide the rover through tricky terrain such as Saita. It aced those tests, Farley says. Now it is our companion, and it is continuing to fly and do recon for us. Go West, young rover collecting and storing samples has also turned out to be trickier than anticipated. Last August, when Perseverance took its first shot at collecting a rock core, mission personnel were optimistic. They had tested the machinery on terrestrial rocks and performed extensive troubleshooting on the software guiding the process. The target rock showed no obvious challenging quirks. The task should have been easy. But the first coring tube was devastatingly empty. To come up with a zero-volume empty tube was just mind-blowing, unfortunately, says JPL's Jessica Samuels, sample caching system lead for the mission. That was never something we were worried about, not acquiring the sample. We were worried about so many other things. The rock, it turned out, had been so altered by water that it crumbled under the pressure of Perseverance's drill, not an ideal result but one that left the team with a useful tube full of Martian atmosphere. That first sample failure was stressful, however, and if the problems continued, they could have scuttled the once-in-a-lifetime chance to gather and return pristine material from Mars. A view of NASA's Ingenuity Mars helicopter mid-flight. Since then the team has regrouped and successfully collected 6 rock cores, which Samuels says is validation that the system actually works as planned. It's not us. It's Mars, she says. Indeed, Mars served up another episode of sample collecting shenanigans when pebbles recently wedged themselves into the rover's sample caching hardware and Perseverance had to do a bit of a shimmy to shake them loose. There's never a dull moment in sampling, Samuels says. It's keeping us on our toes. And it's keeping us continuing to think about the different environmental conditions. Overall, retrieving a small cache of samples from Mars is an audacious task that is just barely within our technological grasp, even if each of the mission's moving parts performs perfectly. We're pushing the limits of the technology we have today to land and launch a rocket from Mars that is essentially just big enough to get a basketball into orbit, says Albert Haldeman, chief Mars engineer at the European Space Agency, a partner in the overall sample return effort. Perseverance's already collected igneous rock cores can be used to measure the strength of Mars's ancient magnetic field and to precisely pin ages on the crater's epochs. For now, scientists guess that water sloshed around in Yezero around 3.5 billion years ago, but Farley says there are 500 million years of uncertainty in that estimate. Soon, team members say, they will begin deciding when and where Perseverance should deposit a preliminary cache of materials, just in case the rover is no longer functioning by the time the next spacecraft arrives to retrieve its bounty. If everything is on board Perseverance, and Perseverance dies unexpectedly, we've got nothing, Haldeman says. So a safety cache will be put down at a potential landing spot, sooner rather than later. Before it leaves the crater floor, Perseverance will fill 2 more of its 43 onboard, ultra-clean sample tubes. Then it will turn west and make haste. We're gonna gun it for the Delta, Stackmorgan says.